Greetings, everyone. Today we are going to explore solving systems using elimination, but specifically in this video, it is going to be systems that are already lined up and that only have special solutions. So if you need more expanded elimination information, make sure to seek out other videos. Make sure that if this is what you need, you're in the right spot in your notes. Alrighty, let's connect back to our last lesson. Just a quick little review. Remember that if I want to eliminate an 8, I need a -8. And so mentally, we're going to have this little checklist of do I have the same number and do I have opposite signs? If I don't, I have to make it happen. What do I mean by that? If I have 5 and I have 15, well, that means I have to take the 5 times -3, right? I can pick any number. I can pick any number that makes this happen. So that would get me a -15, and I keep my +15, and now they cancel. But what if they don't fit into each other? What if I have, let's say, 6 and 5? 6 doesn't fit into 5, 5 doesn't fit into 6. Uh-oh. That means we have to multiply both of them. We have to multiply by the opposite number. But that would take care of the same number, right? If I took a look, that would get me 30 on both of them. Uh-oh, they're not opposite signs. So in that case, you get to pick one of them to be multiplied by a negative. Doesn't matter which one. Okay? But your goal is to make them have the same number and opposite signs. All right, let's take a look at our first example in this video. The first thing I want to acknowledge is that everything is perfectly lined up. Equals numbers, x's, y's. We've got to keep acknowledging that because it's not always going to be true. Next, we want to choose a variable to eliminate. My eyes are drawn to the x's first. Do we meet our checklist? Right? Are they the same number? Yep, they're both 2's. Do they have opposite signs? They sure do. We're ready to do some old school addition, as I like to call it. 2 plus -2, that cancels. Let's drop everything else down. 3 plus -3, wait a second, that also cancels, but I need something, right? I can't have an equation with nothing on one side. So what's anything subtracted from itself? 0. I need a 0 there, right? I can't have an empty equation. All right, let's keep going. What's 4 plus -4? That's weird. It also cancels, but I need something. You can't have an empty equation. That's 0. So let me ask you a question. This is special. Is 0 equal to 0? It is. So based on all our substitution and our graphing and our solving equations, we have our special word answer. 0 is equal to 0. So we have infinite many solutions. All right, let's try our next one. First of all, they're lined up. Second of all, we need to acknowledge, do I have the same number? I'm just going to use the x's first. I do. Do I have opposite signs? I sure do. So we get to jump straight into this example with what I like to call some old school addition. Let's add them up. 3x and -3x cancels. That was my intention. Oh, it happened again. 5y plus -5y also cancels, but I need a number. I can't have an empty equation. So I have to put a 0 this time. Let's look at the right side. 7 plus 3 is 10. Does 0 equal 10? Right? That's my question I'm answering here. No, that's not true. Therefore, no solution. meaning there are no pair of numbers that would work in this system. All right, let's take a look at the next one. We got a few more steps here. First of all, we're lined up. X's, Y's equals numbers. Great. Next, I want to choose a variable to eliminate. If you can, I like to stick with the X's just because they're to the left, they're easy to see. So let's look at those X's. Think of my little checklist. Are they the same number? They aren't, but they're close, right? All I would need to do is take this one times 2. That would get me a 4. All right, but let's also acknowledge, will they have opposite signs? Well, a positive 4 and a positive 4 are not. So I'm going to make this a negative 2. Let's try it out, right? You'll know if it works once you distribute. Negative 2 times 2 is negative 4x. Negative 2 times 1 is negative 2. Negative 2 times 0 is 0. I have the same number for my x's, and I have opposite signs. And notice how I just rewrote it below. So I have this new system, and I'm going to do some old school addition. 4x plus negative 4x, there's my cancellation I had intended. 2y and negative 2y, I didn't intend on that. That happens to be 0. Negative 11 plus 0 is negative 11. Is 0 equal to negative 11? No, it's not. So we have no solution. All right, let's take a look at this last one. Everything's lined up. I'm going to think of my little checklist. Do either of the letters have the same numbers? They don't. How about opposite signs? Ooh, they don't. And so I'm going to use the strategy, put a star by this one. We've done this before, but it requires a little more work. I am going to take the first one, and you got to choose x's or y's. It doesn't matter. And you know what? I'm going to change it up. Let's use the y's. I'm going to multiply the top equation by the opposite y and the bottom equation by the opposite y. See how that would get me a 6 and a 6? That helps me get the same number, but they're not opposite signs. So I also have to pick one of them on this example to be negative. So let's try it out. We're going to completely rewrite this system. If I distribute negative 2, that's negative 18x, that's negative 6y, and that's negative 12. See what I did there? Distributed all the way. Let's distribute 3 next. 3 times 6, 3 times 2, 3 times 4. Now do I meet my checklist? Yep, I have the same number and I have opposite signs. So let's take care of Mortvet's old school addition. Negative 18x and 18x cancel, but so does negative 6y and positive 6y. I can't have an empty equation, so if it all cancels, we need to write 0. Negative 12 plus 12 is also 0. That's okay. Write that out. I need to see 0 equals 0. Does 0 equal 0? Yes. That means that there are infinite amount of points that would work in this system. So we have infinite many solutions. Alrighty, let's do a quick little review. We always have to make sure everything's lined up, right? We then need to choose a letter, choose a variable, and we need to make it so they have the same number and the opposite signs, right? That was our goal on every problem. And then step 3, no matter what, we're just solving from there. We need to solve little mini equations. We need to solve for variables. That's old news. This right here, that's the new stuff that we got to keep working on. As always, make sure to check out Google Classroom, see what your task is today, seek out other videos if you need more help to catch up, and until next time, have a good one.